Okay, so this is our A matrix: 7, 2, minus 3, 2, 5, minus 3, 1, minus 1, minus 6. Okay, now if I want to find the condition of A, I should find the norm of A and norm of A minus 1. Let us say we want to use the column sum norm. If I want to use the column sum norm, I have, for this column, if I do the summation, 7 plus 2 plus 1, it's 10. For this one, 2 plus 5 plus absolute value always, don't forget. So it's 8. And here, 3 plus 3 plus 6, it's 12. And I select the largest element, which is 12. Okay. Now, if I consider the A minus 1, so this is A minus 1. If I perform addition of elements in the same column, okay, فدا please في يعمل summation here and give me the result. So first, for the first one is 0.172 plus 0.047 plus 0.036. حدا نعملها شيء؟
0.255.
0.161.
طب يلا بليز حدا يعيد تنتأكد.
دكتور أنا عم بكتبهم بالشات إذا هون لك.
اوكي مايكل 0.1614 هيدي أول وحدة صح؟
إيه دكتور أول وحدة.
0.1614 okay. Second one 0.255
دكتور أنا السكند وان طلعت معي غير ما بعرف 0.078.
لك إذا 3 elements وما عم تعملوها مضبوط شو قصتكم؟ يلا it's fine.
دكتور in absolute value أو
أكيد in absolute value please.
دكتور دكتور
مش
لكن
هيك.
أنا الغلط
اوكي
صوت ما حطيت
انتبهوا
احنا الغلط وهن الصح.
على طول حطوا بلس اوكي. ما هيدي النورم على طول باخذ الابسوليوت فاليو اوف الاليمنت. طيب فاذا and the last one اول
وحده هي 0.
اول وحده هي 0.255
Yes.
so
Yes, see, I was right.
yes اوكي. مين كان عم يحكي معي اول شيء؟ ليا او نور؟ ليا اوكي 0.255. السكند one يلا مين بده يعطيني السكند one؟ It seems انه اكبر I think
0.328.
okay. And the last one
0.286.
okay. So now the highest one here 0.328. If you multiply 12, it's very good condition of this matrix. Do 12 times 0.328. It's يعني مش كتير كبيرة. Okay. What do you get nearly? هي قريبة على بين 3 وال 4. What do you get if you do it? So it's smaller than 10.
0.9.
Okay, 3.9. Okay, so nearly 4, 3.93, which is good. It's a very condition number. لأنه حتى إذا عم بشتغل على if you remember إنه كنا نقول إنه إذا عندي if I want to see how many digits I can trust, if I do log now log base 10 of 3.93, it's smaller than 1. يعني maximum I can disregard just 1 digit. In the worst case scenario, I cannot trust 1 digit, which is very good. Okay. So what we can say here is that we expect then, if we do A times A minus 1, we will get something very close to the identity matrix because the condition number of A is relatively small. You can also calculate the condition number based on row summation. كمان حيطلع صغير يعني here if you do row summation try to do it, you can find it based on row summation يعني مثلا إذا بناخد for this matrix it's easier to do calculation 7 plus 2 9 plus 3 12. If you take this one it's 2 plus 5 7 and 3 10 and 8. فكمان this is 12 also, it's the same result. Okay, so and here also if you do a row كمان numbers are small, so you expect to get a small condition number, and therefore it's a well conditioned matrix. Okay, this is why you expect that when you do a times a minus 1 you will get nearly the identity matrix. Okay, so all you have to do is to multiply term by term, and you have a, you take the first row. Let us do it in a fast way. Okay, so the first element for example
دكتور
نعم. Yes.
بس فيك تذكريني بليز انه شو يعني we can't trust one digit.
Okay, look,
هيدي
did you
السي
watch,
صح
did
اللي
you watch
لقيناها هلا.
الفيديو did you لأنه it's very long procedure. Did you watch الفيديو عن condition number?
بلا انه بنلاقي سي وتي وبنعرف
Yes,
الار قد
exactly.
ايه.
يعني الايديا انه انت
بس
اذا عندك
السي
a
كيف؟
times yes اذا انت عندك a times x equals to b. Okay, if you vary b, اذا غيرت مثلا b let's say ب 1%. Okay, you expect انه اذا الكونديشن منيحه of your matrix then x كمان should vary in the same amount nearly. Okay, يعني انت you can demonstrate انه maximum variation that will undergo x هي بتكون multiple of the condition number. يعني اذا انت b vary 1%. Okay, you expect انه x will vary the condition number times 1%. فكل ما كان عالي يعني relative variation of x حتكون relative variation of b times the condition number of a. فهون مثلا إذا a is 3.93 يعني you can expect إنه in the worst case scenario if I vary b by 1% then the solution تبعي will vary by 3.93%. Okay, and if we want to talk in terms of digits then you can say that I can trust I can disregard the last digits of x. يعني مثلا إذا أنت الb تنقول فيها 4 digits and x you will take it as 4 digits. يعني إذا x مثلا 3.123 you can say I just disregard the last digit and I can trust the 3 first digits.
اوكي هلا فهمتها. وهول ال 3 first digits هن ال t minus c يعني.
Exactly, هن t minus
اوكي
c. Yes.
اوكي ثانك يو.
Okay, welcome. Okay. So let us move now to problem 2. So here for example قالوا لكم use LU factorization with pivoting. يعني حددوا لنا انه we should use pivoting for this system. So all we have to do اصلا حكينا كثير عن this in the previous example. So since we might require pivoting we should track the pivoting operation or using the P matrix or we keep them at the side. يعني if we start by first the following matrix. أول شيء بجرب اخذ هال pivot equation. I should make sure انه this pivot element is larger than all elements below it, which is not the case. The largest element in this column is 12, so I should pivot rows 1 and 3. يعني already I can write at the side انه pivot 1 and 3. Okay, or I can track this in the permutation matrix. يعني اثنيناتهم صح. Okay, use what you like. يعني what seems for you easier. يعني هون بما انه already من الاول عطيوكم B، لو عطيوكم several B's لازم you should perform this pivoting على كل ال B's. يعني for this vector B I should first pivot to 1 with 3. يعني بيصير الفector 8 minus 862 minus 51. Okay, now هلا ال L بعد ما عملت شيء، يعني ال L بعدها فاضيه، so I don't need to do any pivoting بال L لانه بعد ما عبيتها already elements. Okay, تقدر اعبي ال L بدي اجيب ال factors and I still didn't get any factor، يعني ما حتتاثر بهيدي ال pivoting operation ال L. Now once I do the pivoting now I can start to fill my L by determining what are my factors. أول factors بالelimination حيكونوا F21 equals to 4 over 12 و F31 equals to 1 over 12. And now I will continue with my elimination. Yani I should apply for the elimination to get the updated coefficients. As expected, مفروض يصير هون عندي 0 وقت أطبق على F21. And I should update all these coefficients. صرتوا تعرفوا كيف يعني same technique. For example, if I want to update this term, please انتبهوا هولي ما بدقوا فيهم بالاليو لأنه بالاليو I don't apply the change of coefficients للB vector. I just apply it للA matrix. So please هون حطوها just حدا ينتبهوا يعملوا pivoting. Okay. بس ما بنعمل مش مثل بالGauss elimination. بالGauss elimination we also update these coefficients بالforward elimination. بينما بالاليو factorization as we said we do separation of the two processes. يعني forward elimination I just update coefficients of A just for B أو بستعمل permutation matrix أو I do pivoting step by step. Okay. So now when I perform the forward elimination for yes.
يعني هلا تفهم شو قصدي بالتو ميثود يا بعمل pivoting matrix يا انه بحطهم ب augmented matrix بصير شقلبهم.
هلا فيكي ما تعتبريها augmented matrix كارين، فيكي تعتبري انه بس عم شقلبها معهم بس ما بدي تاخديهم تنتبهي ما تاخديهم بال substitution يعني
انا بفضل ما احطهم هيك
ما تحطيهم ما تحطيهم فيكي بس تحطي تكتبي شو هن البيفوتينج وتعمليهم اخر شيء على البي كمان اتس ميثود يعني هيدي مش ضروري تحطيها ما تغلبتكم اوكي يعني بس فيكم تحطوا على جنب انه I did pivoting 1 3 واخر شيء هون كمان حنعوز 2 3 فمن بعد ما تحددوا كل البيفوتينج done دغري بتقولوا انه I should for B I should do same pivoting procedure انه اعمل minus 51 و8 وارجع اعمل minus 51 و62 يعني بتطلع الاخر شيء بيصير عندي 8 فوق اوكي minus 51 هون و62 تحت اوكي هيدا الفاينل بي اللي حاشتغل فيه to get the forward substitution okay so now when I perform a forward elimination I can update these coefficients بيصير عندي new matrix اللي ببلش كون عم بيطلع لي عم اعمل upper matrix تبعي I update these coefficients وبرجع when I use F31 I update these coefficients. Now I am done with the first step. صار عندي zeros everywhere below the first element. يعني now I cannot use anymore this pivot equation. It's locked. And now I should move to another pivot equation. So I say I will move to the second equation. Then I should check. I should always check if this pivot element is larger or not than all elements below it. طول بتطلع below it I don't look sorry هون هي here this is the matrix so this is my pivot equation I don't look at elements above it just at elements below it 3.667 in absolute value is smaller than 7.083 so I should pivot 2 and 3 and now this is my updated هلا here لازم انتبه since I did pivoting بين 2 3 يعني كمان الفاكتورز اللي كانوا ب L should be pivoted يعني now L when I fill L matrix اللي هي على طول عندها ones على diagonal بالLU factorization وعندها zeros in the upper part please keep in mind انه بالLU factorization ال L على طول 1 على diagonal بس اذا بتعملوا Cholesky factorization lower matrix ما بيكون عندها 1 على diagonal بيكونوا حيلا شيء elements اوكي بس بالاليو على طول عندي 1 على الدايجونال والفاكتورز تبعي هن F21 و F31 بس بما انه عملت pivoting انا هلا بالسكند ستيب عملت pivoting لازم كمان اعمله للال يعني ناو حاقلب هولي حيصير هون عندي حيصير مطرح في F21 في F31 حيصير في 1 over 12 هون وهون حيصير في 4 over 12 okay and finally
دكتور
yes
خلص it's fine خلص انه just بالاخر بسألك
I still have to find just this element okay so now to find this element I find it after doing the pivoting when I do the pivoting operation بيصير عندي ال highest element هون هو بيصير أكبر من كل اللي تحته. So now to find F32 I just have to do minus 3.667 over 7.803 083, sorry, and then I will get my factor F32 and I am done with lower matrix. بيبقى عندي upper matrix to update the coefficients تعمل forward elimination. بس أعمل forward elimination بيصير عندي إنه هيدا الترم بيصير 0 and just I should update this one. So I do 8 minus the factor F32 times the element in the pivot equation in the same column of 8 اللي هو minus 4.25. Okay, so minus F32 times minus 4.25, and now I am done with my lower matrix and my upper matrix. بينما البي ما بعمل له الكوفيشنتس تبعه ما بيتغيروا. just I do pivoting for its يعني او بقرر اعمل permutation matrix واخر شيء بضربها ببي او each time I do a pivoting operation I should perform it also on. Okay. Yes, Mark.
دكتور هو دائما اذا we pivoted in the first step اول شيء يعني اول شيء اذا قبل ما نبلش يعني كان في انه الانيشال ايكويشنز وحده بدنا نحطها فوق لان ما بتتغير ما هيك
لانه بعد ما دقيناها
لانه بعد ما دقينا فيها
exactly
لانه بعد ما دقينا فيها اوكي بس هيك.
دكتور
yes
دكتور يعني نحن بالاليو ما بنغير شيء بالسوليوشن ماتريكس بنتركها مثل ما هي بس نعمل بيفوتنج بينما بالجاس اجباري نغيرها ما هيك
مضبوط. هيدا الفرق الوحيد 100%.
اوكي. ودكتور سؤال تاني يعني هلا كمان نحن بس نعمل بيفوتنج فينا اذا بدنا نترك البي مثل ما هي بس نضربها ببرميتيشن ماتريكس ما هيك
اكيد اخر شيء صح. you have two options او كل ما عملت pivoting وانت عم تعمل اليو فاكتورايزيشن بتعملها على بي او بتعبي ماتريكس permutation ماتريكس واخر شيء بتضرب بي 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 اثنينهم صح.
Thank you.
And now once you are done with LU factorization بيصير كتير هينة. بيصير you want to do forward و backward substitution to get your x. هلا مثلا لو انا اعطيتكم هي البروبلم وخيرتكم بين LU و GAUSS بما انه في one vector B use GAUSS اهين. اوكي. اي متى بتصير عندها advantage LU لما I have several vectors. اوكي. So now problem 3 use GAUSS elimination to solve for the system. So هون إذا بدكم the only difference in this system with the previous one إنه I use an augmented matrix. يعني I should update also the coefficients of B بدي أعمل لهم I should change them when I do the forward elimination process. This is why we say we use an augmented matrix now. The augmented matrix حتكون بالinitial state 5 1 2 4 6 1 1 6 4 1 minus 1 minus 2. Now I should check بما انه it's GAUSS elimination I should always check if pivoting is needed or not. Since I start first with considering this is my first pivot equation I should check that 5 is larger than an absolute value. Please تذكروا absolute value يعني في يكون عندي minus 6 absolute value of 6 أكبر من 1 I do pivoting يعني على طول ما بتطلع بالساين I just look at the absolute value. Since an absolute value 6 is the largest one between these elements, I should do pivoting of of row 1 and 2. Okay. So now in the first step I should do pivoting of these two. فبتصير augmented matrix now. My new augmented matrix بتصير which I will work on is 6 1 1 6 5 1 2 4 and 4 1 minus 1 minus 2. Now what I should do now is I will find factors. F21 equals 5 over 6, F31 equals to 4 over 6 or 2 over 3, and now I will update كل ال coefficients هون مع ال B okay according to the formula. يعني بعمل for example for this element 4 I do 4 minus 5/6 times 6 the element the same column of the pivot equation. Okay, and then when I am done with all three coefficients update, I move to the third row, and for the third row f31 is 2/1. And for example, if I want to update the B element, I do minus 2/3 times. Now I still have the pivot equation, the first one, so times 6. Okay, once I am done with updating these coefficients, the first row is locked, I cannot use it anymore, and then I have to move to the second pivot equation. Now I should check, but I don't look here, I will look at the updated matrix. And now I will look at the updated matrix after doing the forward elimination for the first column. You have all details here in the solution. Okay, so now after doing this, I will get the following matrix. This one. Okay, now I have zeros here. I am done with the first step of elimination. I cannot use anymore this equation, it is locked. I will move to the second equation. So now I will say, so here it is here. This is the second equation, but I should always check that now the pivot element is larger than all elements below it. And I repeat, below it. And I don't compare with one, خلاص, this row is locked, I don't look at it anymore. I look at all elements below the pivot element. 1/6 is smaller than 2/6. So I should pivot, I should do pivoting of rows 2 and 3. And when I do pivoting, now I am ready to proceed because now I have in my pivot equation 2/6 is larger than elements below it. So now if I am ready to find factor F32. F32 is equal to 1/6 over 2/6, which is 0.5. Once I find F32, now I say that all I have to do is to update these two coefficients. Okay, so when I do forward elimination, this will be 0. And for example, this coefficient will become -1 minus 0.5 times, always remember, I take the element in the pivot equation in the same column of the element I want to substitute. So here I should use times -6. So times -6. Okay, and now when I'm done, the advantage here is that I have one B vector. So when I do Gauss elimination, I just need to do here backward substitution stuff. So if I do the backward substitution, I can get x1, x2, and x3. And always I start from x3 because I am using the upper matrix, so elements below are zeros. So I start from the third equation to get x3, then I move to the second one to get x1, then I move to the third one to get to the first one to get x1. Okay, any question on Gauss elimination? Okay, Mahdi, if you don't want to put it as augmented matrix, it's fine, but just you should pay attention to update the elements. Okay, مش مهم الفورم، مهم انه to update both. Okay, so now let us move to problem 4. For which values of A the following matrix is positive definite? So now we want to demonstrate that A is a positive definite. We want to find values for small a such that A is a positive definite matrix. So if we go back to the definition, when we say to demonstrate that A is positive definite, this means that whatever is vector x different than 0, okay, لأنه إذا x is 0 يعني x transpose times A times x will be 0. So the rule is that for any vector x transpose times A times x positive. Okay, so now to test for this, we say let us consider any vector x. How to determine how many elements should x be? You have here when you multiply a times x, what is the condition to be able to multiply a times x? The condition is that the number
Two
of
times.
columns of a should be equal to the number of rows of x. So I need 2 elements, 2 rows for x. So I need x1 and x2. So I will set any vector x1, x2 different than 0. And I want to find for which values of small a, when I do x transpose times a times x, I will get a positive value. So first, I can start by assessing a times x. And once I get the result, I multiply it. I do x transpose times the result. So let us do it together. So first I do a times x. So this is times x1, x2. Okay, equals to, so first 9 times x1 plus 6 times x2. Now, the second element here will be 6 times x1 plus a times x2. So 6 x1 plus a times x2. This is the result of a times x. Now I should do x transpose, which is x1. It's a row vector x1 x2 times the result of times this matrix اللي هي this vector if you want اللي هو a times x. So now if I do the product of these two, I have just to do the first element times the first one plus the second element times the second one. So I will get, my result will be 9x1 squared plus 6 times x1 x2. Now I am done with multiplying the first element by the first element. I add to it the multiplication of the second element with the second element. So plus 6x1 x2 again. And finally plus x2 times a x2, which will give me a x2 squared. Okay, so now 6x1 x2 plus 6x1 x2 is 12x1 x2. So I come up with the following result, that x transpose times a times x is equal to 9x1 squared plus 12x1 x2 plus a x2 squared. In general here, to come up to determine if it's positive, for which condition it is positive, it is good to try to write it as a summation of x squared. Okay, how to do this? You know that a plus b squared is equal to a squared plus b squared plus 2ab. Okay, so here if you look at your terms, you have 9x1 squared is 3x1 squared. Okay, so you can call it a. This is a. Now, this term 12x1 x2 to be equal to 2ab, what should be b? B should be, let us try to do it. So if 2ab is equal to 12x1 x2, so you can write that, and you replace a by its value, which is 3x1. So you write 12x1 x2, okay, is equal to 6x1 times b. So you can see that from here b should be equal to 2x2. Okay, so now in order to appear this term a squared plus b squared plus 2ab, since you don't have b squared, you can appear it in your equation by just doing plus b squared minus b squared. So now if I add to this equation plus 4x2 squared and minus 4x2 squared, then I can say that these elements together will form a plus b squared, which is 3x1 plus 2x2 squared. And I still just have two elements, a x squared, x2 squared, and minus 4x2 squared. So it's a minus 4 times x2 squared. And to have for any value of x1, x2, for any value of x1, x2 to have this result positive, then the condition will be that this coefficient should be positive, and therefore
دكتور
A should be
I
larger.
understood what you said بس ما فهمت كيف رجعتي طبقتيه على الإيكويشن.
Which one? Okay. Look, أنا شو قلت؟ قلت إنه what should be B current هيطلع لي square A plus B square. B should be 2x2 صح؟ هيدي فهمتيها
Yes.
step؟ أوكي.
إيه.
طيب هلا أنت بين عندك هيدي A square، هيدي A square، وهيدي 2AB، بس B square شو هي B square؟ هي 4x2 square، ما عندي إياها. I don't have it here. Okay, I don't have it in this equation. How can I make it present? Okay, كيف فيني بينها؟ فيني زيد على equation 4x square ونقص 4x square. In this way I don't change anything, صح؟
يعني أنا قصدي إنه ليش مش ال A x2 square ساعتها هون أنا بقول إنه ال A is equal to 4.
فيك you can do this. It's another method. Yes, exactly. فيك تقولي the minimum value for A should be 4 anyway to have summation of squares. You can do this. اثنين صح يعني. Okay, يعني A should be minimum equal to 4. Okay? Should be larger than 4 كمان to get a positive definite function.
Yes.
Okay? طيب. Any question on this problem? Okay. So we just still have the last problem, which is very simple problem. Using Cholesky factorization, factorize the following matrix. Please, you should understand how to use Cholesky. يعني you should understand the concept. لأنه أنا فينا أعطيكم حيلا n. فينا أعطيكم 2, 3, 4. يعني نحن we derived in the course for 3, and now we are doing the example for 2. So just you should know how to derive it. مش بس to use the final solution. Okay? So here, since it's a 2 by 2 case, which is different than 3 by 3, I can derive how to find, using Cholesky, how to find factorization. So Cholesky method says that هلا هون بما انه they told me use it, so اكيد this matrix satisfies conditions اللي هن symmetry I can see it directly. It should be positive definite, so I can make sure انه this is positive definite. But since they told me use it, يعني اكيد I can use it, so I can be sure that the two conditions are satisfied. So now if I want to use it, I can say that this matrix, according to Cholesky method, can be written as the product of a transpose of an upper triangular matrix times the same upper triangular matrix. Okay, or also, which is equivalent to say that it can be written as a lower matrix times the transpose of lower matrix. Okay.
دكتور اللور هون قصدهم مش الفاكتورز مثل العادة، بس نحن أنا ما بعرف أعمل لور بس بعرف أعمل أبر.
ليش؟ ما هي ذاتها كارن. تنعملها لور. إذا عملناها لور ال كيف تكتبي؟ يعني فيك تكتبي إذا L is a lower matrix تكتبيها هيك L عندك إجباري يكون لأنها lower. أوكي، إجباري يكون عندك 0 here بالupper part، وعندك هون L11 L21 و L22. أوكي، you multiply by the transpose of it يلي هو L11 0 L21 و L22. Okay, and now you should find what are the three unknowns L11 L21 و L22. all you have to do now is to do the product. If you do the product, what do you get? أول element هو first column يطلع لك L11 square. second element بيكون L11 times L21.
دكتور هيدي لازم تكون L12 بعتقد.
أيها؟
L21 بالترانسبوز.
لا، ما أنا عم باخد الترانسبوز. ما أنت هيدا عم باخد ترانسبوز. كيف؟ يعني L11 L21 بتصير first row here.
يس، ما انتبهت.
اوكي، والا ما بيعود تاخذ advantage of transpose، هيك بتخفف number of unknowns. اوكي، so عندك L11 square. now second element حيكون L11 times L21 plus 0 The third element here will be, I now use the second row times the first column. يطلع لي L21 times L11. And finally, if I do second row مع second column, يطلع لي L21 square plus L22 square. Okay. Now if I use the comparison, لازم L11 square تكون equal ل 25. So I get that L11 is 5. هلا فينا اخذ كمان minus 5. اثنيناتهم صح. فيكم يعني تشوفوا انه you might have several possibilities. So I take one of the possible solution. L11 equals to 5. Then now I move to now I can determine L21. لأنه L21 times L11 is equal to minus 50. So I can say now that L21 is equal to minus 50 over L11. يعني minus 50 over 5, which is minus 10. I still only have to get L22. يعني هون ما في لزوم أعمل comparison لأنه already I got L21. أصلاً if I do comparison بيطلع لي same result since minus 50 minus 50. So now I just have to use the final comparison. I have that L21 square plus L22 square equals 201. If I replace L21 by 10, by its value, minus 10, and the minus 10 square هي 100. But if I take it to the other side, بيطلع لي L22 square equal 1. يعني L22 is 1. And I am done. Once I get the elements of my lower matrix, I can deduce the upper matrix, اللي هي transpose of it, and then I did the factorization of I into a lower matrix times an upper matrix. Any question on this?
دكتور انت بتحددي لنا lower او upper ولا نحن
إذا ما حددت لكم you are free to use what you want. إذا حددت لكم you should use what I told you. Okay.
Okay.
Doctor.
Yes.
Chapter 11.
Yes.
هو ما عندنا انه assignment عليه من هيك انه ما
بلا
خصه الassignment هو
بلا اكيد
شو
ما انت شوف الانفرس كله هيدا عن الشابتر 11. الانفرس ماتريكس بال11 فوتناها بس في الكونديشن نمبر في بس الكونديشن نمبر عملت لكم هلا على اكزامبل يعني اللي هو الوحيد مش تيستد بس بالكورس ماتيريال كثير حكيت عنه وقعدنا فول سيشن عنه يعني we did a lot of examples
بتشابتر 11
yes
اوكي وبعد شو اسمه يعني بوينت يعني نمبر 1 بوينت سي هو chapter 11
yes exactly
أوكي.
بس كمان عم تستعمل اليو يعني you are
صح كل شيء عم تستعمل
yes.
chapter 10 و chapter 11
10 و 11 exactly هن related chapters
الفرق بس ال 11 عن الانفرس ماتريكس كيف نعمل الانفرس
مضبوط وعن الكونديشن نمبر كمان
الكونديشن
وفي
نمبر
chapter 9 كمان في زياده انه الكريمرز رول you should know how to do it بس انه it's very simple يعني منشان هيك
الكريمرز كده هي ما
حطيتها exactly
طيب
هون يعني فينا نقول 5 وفينا نقول minus 5
yes
okay
okay guys يلا if you have any question you can send me your questions anytime okay يلا see you tomorrow bye
bye doctor
bye